Hello everyone, good evening.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening.
Good evening.
Good evening.
Okay, so you all have received the announcement, right? This is the last activity session. And from next week onward, we will be having only 2 sessions, open and solve with us, and some special sessions. And the information will be shared through Telegram group. Right? You all can.
Sir, why is that so?
Classes were good.
Sorry, sir.
Because in the previous session, a lot of students demanded that CT is doing that and they want something like that. So it's just an experiment for week 9. Okay, if it
To
didn't go,
hold a less number of sessions.
no, there will be 2 sessions, solve with us and open session, which are fixed on Sunday and Tuesday, right?
Okay.
And these sessions are just like this. It will be streamed on YouTube, it will be recorded, and it will be available further, right?
Yes.
But these sessions will be like, suppose on Wednesday there is no session, right? And the grades and submission day, you guys still, there are some guys who studied that day and they had some doubt. So suppose I am free at Wednesday, so I will post in the channel that I am free and I'm available in that Gmeet link from this time. So whoever have doubt, they can join and ask. And those will be kind of just interaction kind of. They won't be recorded live stream. It's just a simple
doubt clearing sessions.
Yeah, just like that. So it's days and date, like it will keep on changing date and time. Like whenever me or Prashant, whoever is free, will post it on the channel.
And what about the Zoom sessions? They are reduced.
Yeah, it will be only on Sunday and Tuesday. It's for the week 9 only for now. If it goes well, we will.
But like without activity sessions, that will be a problem, I guess.
No, we can still cover it in the open session, right?
Okay.
Yeah. It's just see, if you all liked it, we will continue. Otherwise, we will get back to this normality. A lot of students demanded it in the previous session. That's why we did it.
Sir, for Thursday, there will be no class for summarizing the week content.
We will do it like we are planning.
Thursday, no, Friday, today's class.
Request was different and you took it in a different way. What we requested, CT is taking 3 sessions per week and they are weekly twice or thrice. They are keeping on-demand sessions for 1 to 2 hours. But you cancel the session and you kept the on-demand session.
No, we had first with them, like they said they are doing only 2 and 2 to 3 on-demand sessions. So in total, they are doing 4 to 5 per week approximately.
So you are going to do 2 to 3 on-demand sessions or only 1?
Yeah, we will do 2 to 3, not only 1.
Instead of this, you said on-demand session, 1 on-demand session.
No.
Sir, that means Friday you will not avoid the class, no? This Friday's class, because first day of the week we need to revise the content, no?
Yeah, we can do that. Like we will just
summarize.
Yeah, we will try to do this session.
Yeah, this session and it is nicer.
Okay, moving forward. Okay, so how many of you covered week 8 till now?
Hello, sir.
Hello.
Almost.
Yes, I have doubt in generalizing multiplication rules. That is how many I am do not able to apply this theory.
Okay. Multiplication rule. Okay.
Yes.
Okay, so you're troubling in the questions or in the concept itself?
Sir, in the concept.
Question, sir.
Sir, I have a problem in activity in lecture 3.8.3.
Okay. Which question?
8.3 example.
8.3 even I have, sir.
I too.
Difficult. It's very difficult, sir.
8.5. For me,
2,
one question
4,
is
2, 3,
8.5
4.
also.
Okay, you guys having concept in this lecture 8.0
Yes,
or
sir.
activity
Sir,
question
I have a
8.0?
problem in lecture.
Activity,
I am not
sir.
able to understand.
Okay, one by one.
Lecture only. Lecture itself, one problem is given. Deck of
Yes,
cards.
yes,
The
sir.
deck of cards.
And 8.5 first question.
Good. Okay, can anyone tell me the timestamp?
Yes, 8.5 deck of cards.
Sir,
This
Yes,
one.
yes,
yes,
sir.
go ahead.
This
Yes,
is the
that is.
problem.
Yes.
That each polar is exactly one is. Okay. So ma'am had this question in different way. You can also do it in a bit different way.
Sir, I'm
Here I
not
have
able
To know the
to.
different way.
Here
It's a-
for choosing first is sure event, that is probability equals to 1. The ma'am said that's not clear for me why it is 1.
Sir, I doesn't able to how to initiate this question.
Even for me, sir.
So there must be another way, another approach to do this question.
Yes, sir.
Yeah, we can do a computer that each polar is exactly one is. Okay. So 15. Yeah. Instead of making these 4 events, you can look, see, this question can also be done in another way. Ma'am has done it this way to give you the illustration of multiplication rule. It's not like you have to do this question like that only. We can do it in different ways as well.
Yeah, I know the other method also. Please explain me why P of E1 equals to 1. That is, I'm not able to understand that point, why it is 1. I was thinking it as 1 by 52, choosing an S.
Yes, square. I think I will have to look at it a bit.
It's explained here itself only. You can play here.
So can you tell the other methods? Like,
Yeah, we can do the other method as well. Case of spade is in any one of the piles. Okay. Okay, I see. E1 will be. Okay.
That part I'm not able to understand. Even why even is 1. Rest all I understood.
Okay, so E1 is okay. So you have 4 piles, right?
Yes.
This is P1, P2, P3, and P4, right? And
Yes.
in total, you had 52 cards. It got split
13.
into 13 each, right?
13, yeah, each.
So you are splitting all the cards, right? You are not left with any of the card. All the
Yes.
cards are split in 4
Yeah.
piles. So
Yes.
Ace of Spades is also one of the card.
Yes.
Yes, sir.
So it must be either on these piles, right? Either in P1, in P2.
Yes.
It could be.
Yes.
So that's a sure event.
Normally choosing one card is 1 by 52, right? Probability.
So this is
Yeah.
4 deck, no? So 4 choices.
We are not choosing. See, the event is the Ace of Spade is in any one of the piles. Yeah, it is a sure event, right? It would definitely
Yeah.
be either in P1,
And-
P2, P3, P4.
But we need to pick one card, no? From 52 cards, we need to pick that Ace spade.
No, you don't have to pick any. You are just dividing it. And after that, you said that Ace of Spades will be in any one of the piles, which is a sure event. Like, yeah, it will definitely be in any. It is not possible that Ace of Spade won't be in any of the piles. Right? We have distributed all the 52 cards.
Yes.
Because this sure event only here only it came. Rest everywhere 1 by 52, 1 by 30, like that only came.
Yeah, the event is defined like that. Here we are not choosing only one single card. Here we are talking about all the 4 piles.
Okay.
So tell me different way to solve it. I am not able to understand this question.
Let me see another 52 card. 4 piles,
Actually, that is not picking, just
So that is a 4
that is
pile and
placing
4
inside
chance.
of
It
the
is
pile.
like that. Ace is coming.
Okay, so in total we have 52 cards. We have 4 aces and 48 others. This is the first, second. Okay, so see, first there in the first pile there will be 13 cards, right?
Yes, sir.
Yes.
So, and I need one ace and remaining 12 from the other. It would be any of the ace, right?
Yes, sir.
So filling the first pile, I can like choose one ace and get it here. Right?
Yes, sir. This
And
is
from
the thing, yes.
remaining 48, I can get 12. Right?
Yeah.
Now I'm left with 39 cards, right? And of which 3 are ace and 36 others, right? So for the second pile, I can choose one ace of the remaining 3 and 12 remaining from the others category, right? After that, we'll be left with only 26 cards, and of which only 2 ace will be left. Like one ace had already gone here, one is already
Yeah,
here.
the second one, yeah.
So I'll just 2C1 times 12, and then I've already distributed all. Like I have only 13, one ace and 12 others. So that's 12C12. And that's a total number of ways, right? Like our favorable outcomes. But in general, it would be we are picking up any 13 card out of 52. Here we are picking any out of 39.
26,
13.
13.
That's complete. That would be one only. And all these, if you have to go by multiplication rule in this also. Like if we define the first event like this, right? Okay, you all know why the conditional probability, you all understood, right? What it is, what it means.
Yes.
Okay. And how it
The
affects the
procedure
sample
told by
space.
math, if we understood the procedure told
probability
by
only,
math,
right?
it's easier.
Sir, can you summarize the week fully?
Okay,
Okay,
you all know how
portion.
conditional probability affect our sample space.
Yes, sir. Like the samples will be decreased because some of them have already taken place.
Yes.
It's just
Reduced sample space, it will become.
okay. I will summarize it by using Venn diagrams only. Okay. Okay. Suppose these are two events. Okay. This is event A and this is event B. Okay. So in general, this is our complete sample space, right? So whenever you have to find probability of, let's say, event A, it is same as this region, green region. This complete green region divided by the complete sample space, right? That's our probability of A in this whole sample space. But when we say that event B has already occurred, right? This suppose event A, event B, we are saying that this event has already happened. So if this event has already occurred, then anything outside this cannot happen because it is not inside B. If B has already occurred, then happening of this point is not possible. Happening of this point is not possible. Only things inside B can happen now, right? So our new sample space is reduced to B now. That's what it means when we write no probability of something given B has already occurred. It means our new sample space is just this much region now. We are not looking at the complete original sample space. So if I talk about probability of happening of A given B has, so if you look at my favorable thing reduced to this only, because outside region like this red shaded region, it cannot happen now because it is not inside B, and if its orange region has already occurred, only thing that is possible to happen is within this orange region only, not outside it. So that's why we find it like A intersection B. And my total possibilities is nothing but this complete orange region now, which is my new sample space. Another way to visualize this is In general, you can also write it as this, right? Given the complete sample space. So even if you write it, so P of S is nothing but 1 and A intersection S is A. So that's just, you can also write these event as conditional, but we don't usually do that because S is our original sample space, so it's no beneficial to write it. But for if some event has already occurred, we represented that, yeah, this is my new sample space now. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Can we do activity question 5? Activity 5, question 2?
Yeah, we can do it. Just few more, one more concept. Like
Independent events.
Yeah, independent is coming at. See, if the probability of happening of this, right? This much probability of A is nothing but this much portion out of the complete sample space, right? If this portion, okay, which is nothing but when my samples, yeah, when my sample space was S, right? And the portion of A when my sample space was B. If these two are same, by proportion, I means it's green area divided by complete blue region, complete sample space. While in A given B, it is the green region proportion to the complete orange region, right? Like what percentage of this green region is out of complete orange region. And here in the S, what proportion of this green region is out of the complete blue box sample space. If these two proportions are same, we say that happening of B didn't affect it, because I still have the same percentage of chances of happening of A, whether I mean the original sample space or in the conditional sample space. So that's when we say that the events are independent with the proportional same. It is same as probability of A, right?
Sir, I didn't understand that. Could you repeat that?
Okay. See, this is my original sample space, right?
Yes.
And I have two events in it, event A and event B. Okay. So if you look at the complete sample space, it's complete rectangle over here, right? And event A is just this much proportion of complete sample space. Okay. So this proportion of A, I'm just denoted by probability of happening of event A, right? That's what we mean in general.
Yes.
And now suppose I am saying that event B has already occurred. Event B has already occurred, it means that my new sample space is this. Now anything outside B cannot happen.
Yes.
And within this B, the happening of A chances are this.
Intersection.
So my new sample space is B, right?
Yes.
And the proportion A hold in this sample space, if it is same as the proportion that A hold in the original sample space, if these are same, it means the happening of B didn't affect my chances of A, right? It is still same.
Sir, then if we look at it as a set, then don't you think A will become subset of B?
A is not a subset of B. It's not. That's why we take A intersection B, right? Because that's my new sample space. So any other event should occur within this sample space only. That's why for any other, we take this intersection part only. We are talking about only this region now, this B.
Is there any special to represent independent events in Venn diagram?
Yeah, that's what I told. If this red region in the complete sample space, right, this proportion, if it is same as this green proportion of this complete orange area.
This one I understood, like disjoint set, we will make it separate, right? While drawing. Like, is there any way to draw a disjoint?
No. Independence is the only thing which you can't even tell intuitively. Okay. You will always have to check it. Okay. If you plug in, if you open it, right? Yes. A given B is nothing but A intersection B upon this, right?
Yes.
And if you multiply both sides by probability of B, that's what we say is the multiplication rule.
Okay.
That's the condition for independence, right? So this condition is
While,
derived from this.
while
one.
drawing the Venn diagram, there is nothing special. It looks
Yeah,
like
nothing
not
special.
regular.
Yeah, yeah.
Okay.
Is this clear? Or still anyone have doubt in this?
Yes, sir. Yes, sir.
Okay.
So, sir, we are saying if supposing probability of A is 0.5, then probability of A given B should also be 0.5, then we will say they're independent events.
Yeah. Okay. See, if we are saying 0.5, it means that this red region, right? This red region is holding 50% of area of the complete sample space, right?
Right.
And if A given B is 0.5, it means that this green region holds 50% area of complete B.
Yes.
So my chances of happening of A is same. Either my sample space is this complete rectangle or only this region. So how did it affect? How did the happening of B affect my A? It didn't affect it at all, right? It's still same. So that's what this condition. This is the condition for independence, which we simplify it as this. You check these things, right?
Okay.
I have doubt in the lecture related to independent events. Can you explain?
But doubt in this is the only thing for independence.
8.5. This is okay. 8.5, fourth minute. One question is there.
So question 2.
Yes, 8.5, fourth minute. Timestamp fourth minute. I'm unable to understand this. Why these are independent events. Yes.
Which ones?
E1, E2, E3. Yeah. Is E1, E2 independent? E1, E3 independent.
E1, E2. Okay, E1 is outcome is 3. And outcome is first outcome is 3. Okay.
Yes.
You know my complete sample space has 36 elements. This one.
Yes.
The samples will consist of 36 elements, right?
Yes.
My E1 is that first outcome is 3, right? First I result in 3.
Yes.
So it would be 3,1, 3,2.
This computation part, that is okay, but first, how to interpret this question? How to comprehend?
You just see for independence, I already told you. The only way you can tell independence is just by checking. You cannot intuitively say ever.
Ma'am here explained before calculating, ma'am briefed it first. You can play that now once. After that, ma'am went into the calculation.
Okay.
The table she wrote, na first row, second row, first row. Here she explained why these are independent and dependent.
Yeah, she has also drawn and tells you in terms of proportion, right? That if
Yes,
this is happening, this is happening.
Yes,
Yeah,
sir.
that's what you always have to do.
But I'm not able to understand because for 7, she said when 1 comes in the first row, we cannot get 7. We can
cannot
get
get
7.
8.
No, we cannot get 8.
7.
Ma'am told
We
like
cannot
that.
get 8.
Yeah, we can only get max 7 as maximum, right?
Yeah,
Yes,
6
we
plus
cannot
1
get
is.
8 when it is first row 1 and 1. We cannot get. That's why she said independent. That's I'm not able to understand.
That's what. No.
No, it is
you
not
get it
like
in
that.
a different sense. It's not like
That is not independent.
you have to go through the lecture again. I think you have misunderstood.
It is not like.
Ma'am said that only. You can play just
Hello,
it's
sir.
only 2 minutes.
No, I don't think. Independence you can never tell just by seeing. These are not the intuitive way.
Only E1 and E3 are independent, but the other one is not.
That's what I'm saying. You by drawing the table, ma'am first declared these are independent and approached the calculation method to prove it.
Is it?
Yes, you can play it. Just only 1 minute.
No, that time she told one is 6 by 36 and the other is 5 by 36.
That
no?
went to the calculation later, but first ma'am here briefed itself and confirmed.
That is 8 depends on the summation. 8 is depend on the first row. So that's why she mentioned. So it depends.
Yeah.
So that independent is not. But it is not in the case of summation with the 7.
See, ma'am has word the use intuition. She is still not guaranteed you that these will be independent or dependent in some sense. These are just an intuition. You still can never say that these two are independent just by seeing
That
the questions.
intuition also, how it related to even, that I didn't get how it's related to the first outcome is 3.
It is no, not for the first outcome. Ma'am said if the first outcome is 1, right? Then the total you cannot get 8.
That is fine.
Yeah. So in some sense, the sum of getting an 8 is depending on your first die, right? You should get at least 2.
Yes.
Or something greater than 2, right? You should get at least 2. So that's the intuition that I'm talking about. She is not saying that these two events are independent.
So this is nowhere related with the event even.
Yeah, no, it's not. It's just ma'am just talking about that. Yeah, 8 is in some intuitive way it is related. You can see that if you get 1, you cannot get 8. But still, you will always have to check with the calculative part.
Okay, I thought it as it's respective to the even event.
No, it's not.
Okay,
it's
fine.
just about the first throw and 1 number. Okay.
Okay. So every time we need to do the calculation and we should prove whether these are independent or not.
For independence, yeah, you always have to do.
Okay.
Sir, I have a doubt.
Yeah.
Is independent events always mutually exclusive?
It can never be mutually exclusive.
Because
you studied the conditional probability, right? A given B, which is kind of equal to probability of. These are the condition for independence, right?
Yes, sir.
If I open it, if these two are mutually exclusive, then it will always be 0, right? Because if these two are mutually exclusive, then intersection part is always 0, right?
Yeah, they don't have any common path.
Yeah, so it
this
want to be always equal to probability of A. And we assume A to be some greater than 0 probability. So yeah, whenever the events are given disjoint or mutually exclusive, it can never be independent.
Sir, if two events A and B are independent, then why their complement should also be independent?
Their complement should also. Okay, if you want to look at through Venn diagram, okay. See, this is my event A, this is my event B. Okay, so the first way I tell you that the proportion of A is this much, right? So the remaining portion belongs to the A complement region. Any region outside this pink area, right?
Yes, sir.
And if we move to the conditional thing, okay, this B has already occurred, right? And this is, let's say, the A intersection happening of A is this much region, right? Anything outside this is A complement, right? So intuitively, if you see that if the proportion of A in this complete sample space, right, if it is same as this proportion of A in my new sample space B, then reverse will also be true, right? The proportion that did not belong to A will be same as the proportion that didn't belong to A in B. If this is true, it will imply this, right? If suppose this pink region is 0.4, so outside pink region will be 0.6, right?
Yes, sir.
And if A and B are independent, then my blue region will also be 0.4. So outside blue region should also be 0.6, right?
Yes, sir.
If A and B are independent, then complements
Yes,
will
sir.
also be kind of same. Okay, that's some Venn diagram thing. And you can also prove it like in some sense, right? A intersection B equals, if A and B are independent, this is the property we use, right? And to check for the complements, you have to find the value of it, right? And you have to prove that it is equal to product of probabilities of A complement and probability of B complement, right? So you can write it as Yes. You know the De Morgan's law by now, any chance? Yes.
Oh, that
Yes, sir.
P of
Yes.
Yeah, so this is just a De Morgan's law we used, right? And the complement I can write like it is same as this thing, right? Probability of complement of event is same as 1 minus probability of event.
Minus, yeah.
So you can now open the union thing. A intersection B. If you look here closely, you can write this as probability of A complement, right? Minus probability of B, and A and B are independent, it is given to you. So you can write it as the product. Here also you can take probability of B as common. And you will get something 1 minus probability of A, which is again nothing but probability of A complement. Now if you take probability of A complement in these two terms, you will get something just again this. So you can prove it mathematically also, but the Venn diagram intuition was this: if this pink proportion of the complete sample space is same as blue, the remaining will also be the same, right? Similarly, if A and B are independent, then A complement and B complement and A, these three will also be independent, like any combinations you can make. Yeah, is it clear?
Yes, sir.
Yes, sir.
Okay. Someone was asking activity 8.5 also.
Activity
8.3
8.5,
also.
question 2.
Question 2. Suppose that we are rolling two pair four-sided die. Okay. Multiplied both dice show 2. Okay, so how did you approach this question? The one who asked this.
So I didn't know how to do this question, how to approach it.
Okay, going to roll two fair dice. Okay. Okay, so whenever we are rolling two dice randomly, or we are rolling the same dice twice or thrice, these things are assumed to be independent. Okay.
Yes.
So in the first throw, I could get any of these 1, 2, 3, or 4 because it's four-sided die only. And also on the second die, the same. I could get either 1, 2, 3, or 4. So probability that I will get 2 in the first die is nothing but number of favorable outcomes upon total number of outcomes. And similarly for second dice, it is also same. And since these two events are independent, just simply multiply. You'll get your answer. Okay. Or if you want to define it in the event way, you can do it like this. Getting 2 on first die, and E2 could be getting 2 on second die. So you should get 2 on the board die. So in general, you need this, that E1 occurs first, I get 2 on the first die, and then I get 2 on the second die as well, given that 2 has already occurred on the first die, right? But E1 and E2 are independent because I'm rolling two different dice. So if this is independent, then you can just write it as this, or it's 1 by 4 times 1 by 4 again. 16. So you can do it either way, thinking like that or that eventually. Okay.
Thank you, sir.
Okay, next, who was asking? 8.5. Yeah.
8.3.
8.3. Okay.
2. Question 2. Actually, sir, I am not. Actually, I am not get the lecture. So the ma'am in the lecture. Sir, actually, ma'am, sir, I am not able to understand in the lecture examples also.
Okay. Okay. Let's do this one. Okay.
So that's why this question not
First
get
card
it.
is ace and second card should be diamond. Right? Ace of club as well. Okay, so let's simply define the two event, right? But the first card should be ace of club and second card should be just diamond. Okay. So in general, you have to find the intersection thing, right? Right. My first card is ace and second card is diamond. Right. Now using multiplication rule, you can write it like that, right? It is the same thing, right?
Yes.
Okay. So probability of even is getting ace of club. So ace of club, we have only one card out of the 52
One.
total.
Yes.
52. Now if we move to this
Okay.
conditional sample space even has already occurred. It means now I am left with only 51 cards. Or you can say
Okay.
52 cards in total minus ace of club. I don't have any more, right? So out of these 51, I have 13 diamond cards, 13 spade, 13 heart, and 12 club cards only, right? Because one is already drawn. Even has already occurred. And I am not
Yes.
replacing the card it's given to me. So out of the total 51, I have 13 favorable. Just have to compute it. Had it been that we are doing with replacement, then it would be just 52 again. Just try to simply define the events and then go step by step.
Okay.
Okay. Anyone, anything else?
In activity 8.7, question number 4.
8.7. Okay. 8.7 base rule. Yeah, you're gonna face some base storm in quiz 2 as well. Question number 4. A particular task is completed. Okay, what are the I think RSP 1/2, 1/4, 1/8. Okay, so I have to just find that the task is completed, right? This is my main motive to find. Okay. So in how many cases the task can be completed? The first way is the R did it and other two did not, right? Second way is S did it and other two didn't. Third way is P did it and these two didn't do it. In all the three cases, my task is still completed, right? It is also possible that R and S both did it, but P did not. In that case, also my task will be completed because R or S, like they have already done it for me. It is also possible that R and P have done it, but S didn't do it. Or R and let's say who's the one? R and S didn't did it. P did it. Okay, and R and P didn't did it. These are all the 7 possible cases, right? So one way is, and all of them are doing independently as well. So one way is you can just simply find that probability of that R will complete is 1/2. Or let's just define the events better. That R completed the task.
2 and 7 are same, sir.
Sir, 2 and 7 and 3 and 6 are same, I think so.
Yeah.
Okay. I think I have drawn.
6, S and P are completed.
Yeah, S and P both.
That's the case.
And here, so these 2 have completed, he didn't. Right? Now it's different,
No.
right?
5 and 6 are same, sir.
So it would be. Let's.
So there can be possibility where all three can together work and complete the task.
Yeah, that we can do, and one case is still missing. That is
yes and P
wrong.
completed.
Yeah, okay, yeah, these 7 will be the case, right? E2 will be S completed the task, and E3 will be P completed the task, right? So the first case is nothing but probability of E1, right, into probability of E2 complement, right? E2 didn't complete the task, given E1 has completed. The third one will be E3 didn't complete it, given that E1 has completed and E2 has didn't completed it. And we know that these three are doing it independently, so you can simply remove the conditional. That's what independent can do a lot. That's the first case. Similarly, the second, third, all 7 you have to do. So that's very tedious task. Another way to do is you can just simply do it 1 minus probability that task is not completed, right? That's another way to do it. It will still give you the same. Yeah, so task will not be completed when all of them didn't do it. So I can simply write, and all of 3 of them are doing it independently as well. So I can simply write it as A didn't complete, R didn't complete it, S didn't complete it, and P didn't complete it. And then you can simply compute it. E1 complement is 1/2. E2 complement is 3/4, and it's 7/8, right? You will get your answer 43/64, right? Is this clear or any doubt in it?
Yes, clear.
Yes, sir. Can you show how to do question 7 also in the same activity?
Question 7. Okay, this question is, I think similar question is also in the graded one. So, okay. Suppose Madras. Okay. Okay. Did you try this question?
Yes, I tried, but I didn't get the correct answer.
Okay, moving on. Okay, I will just illustrate with the bit Venn diagram as well. Okay. Okay, so I am given that 40% of students are girls, right? So we can simply divide it in 2 regions. This is the 40%, which is the girls region, and here 60% boys region, right? It is known that 70% of boys play cricket. 70% of, okay. 70% of boys play cricket, right? But do you stand by this statement, whether it's intersection, conditional, or what it is? Okay, suppose my C is an event, cricket, right? B be the event that selected one is a boy, and G be the event that it is a girl. So see, here we are given that 70% of boys. So we are already in this region, boys region. Within this boys region, they play cricket, and its chances are 70%, right? Next statement is 60% of girls play cricket. So 60% of girls. So we are moving to the girls area, this purple region. Of those playing cricket, we have 60%. Right. So you are seeing that how we are moving to conditional probability by these statements. 60% of girls play cricket, right? So you have to interpret these English in terms of like whether it's intersection given or conditional given to you. After that, one more thing that is given to you. Given this, 33% of those who play football also play cricket. That is something. Those who play cricket also play football, right? So whenever we are saying that 33% of those who play cricket, so we are moving to some cricket sample space, and within that the chances that someone plays football is 33 by 100. If given C, those who play cricket also play football. Okay, it's given. Those who play football also play cricket. Yes, it's just reverse. Football, cricket. So we are moving to the regions of football, and after that we are defining that within this football region, 33% are also playing cricket. So you're getting how we are differentiating conditional with intersection. This is not intersection, it is conditional, right? Is this clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so after that you have to find F given C, right? If I'm not wrong, this is the thing you have to find. So to finding this, you need two things: F intersection C and probability of C. So probability of C, okay, so if you look at the Venn diagram, C would be some this region, 70% of this region over here would be 70% of the complete red region, and this region over here will be 60% of the complete purple region, right? So to find someone plays cricket, we use law of total probability, right? The region which belongs to the green region which belong to the red, and the green region which belong to the purple. If we add those two, we will get the total, right? Intersection, we can write it as something C given B, and here also we can split it, right? Using law of total probability, that's what it is. And you can compute this. It would be something 0.66. So you got the denominator. For numerator, you need F intersection C, which you can compute it from here, right? The LHS is, it is given to you 33 by 100. You have to find probability of F again using the some law of total probability, right? Is this clear?
Yes, sir.
See how drawing the Venn diagrams can also simplify the problem a bit. You can interpret the English statements a bit easily.
Actually, drawing this type of Venn diagram is new for students actually.
Yeah,
We
that's where
draw 3 circles.
no, see, if you look at properly here, in general, I had this complete sample space, right? Then I divided it into two regions because either it will be boy or it will be girl. So I am given that 60% region belongs to the boys and the remaining 40 to the girls, right? After that, this statement occurs: 70% of boys play cricket. 70% of boys, it means 70% of this red region complete belongs to some cricket, which is this. And 60% of girls play cricket. 60% of girls, it means 60% of this purple region belongs to the cricket one, right? So that's how drawing Venn diagram can solve a bit problem for you. And there will be one more circle if you look properly for some cricket as well. Oh, football, sorry. So, and you are given that this within the football, the cricket region is this 33%. So it will get a bit messy in some cases, but yeah, it will still help you solve the problems a lot.
Normally, we learn to draw 3 circles, one for cricket, one for boy, one for girl. Can we do like that also? Can we solve this like that?
You can do it, but you also have to do the split of girls and boys. It's just like the rectangle divides into 2 parts. It's nothing else. It's a split.
In this, we were supposed to find the probability of someone playing football given that they play cricket, right?
Yeah, this thing. Yeah.
So we have found out probability of playing cricket.
Yeah. This law of probability. You can also find probability of F as well.
Then how will we find out probability of cricket and football?
Cricket and football using this.
But here, do we have the probability of football?
You have to do it again by law of total probability. See, these statements are given to you as well. So only 70%. %, of student who plays. It also plays that F given B. B given F is 40. Yeah. See, it is assumed that everyone is playing something, either cricket or football. It's something like that scenario. So the region which does not belong to the cricket will belong to the football. So if it is given that 60% of girls play cricket, it means that the remaining 40% playing football. It's something like that.
So we're saying probability of F given G is 40.
F given G. One
Is
minute. Let
40.
me just see. Let me just read again. It is known 70% of boys play cricket, right? This statement we have covered. Right?
Yes.
60% of girls play cricket.
Yes. We
So
did
yeah,
not.
here the information is given. 40% of the boys play football.
Yeah, F given B.
Yeah, 50% of girls play football.
G given F.
No, F given
Sorry,
G.
F given G.
Yeah, so you can find probability of F again right now using law of total probability.
The way we found C. Okay.
Yeah, you know this. Probability of F will be this thing, right? Either it is a boy or it is a girl, right?
Yes.
If you split it again, probability of boy I know. This thing is given to me.
Yes.
This thing is also given to us. So I can find probability of Fs using law of total probability.
In the same manner that we did for C. Okay.
Yeah. If I
and then
put
putting it
here,
in there, they can find F intersection C.
Right, and then you got this. That's your answer straightforward, right?
Yes. Thank you.
It's a bit lengthy, but yeah, law of total probability and Bayes theorem goes like that.
Yes, it's quite lengthy.
So in quiz, these questions are generally split into 2 parts. First question is something like only asking probability of C or F and then going into that in the second part.
Yes.
So it would be just like 6, 7 numbers or 8 for such question. Okay. Anyone, anything else?
Sir, I have doubt.
Yeah, in which question?
Sir, activity lecture 8.3.
Lecture 8.3.
Actually, 8.3 probability question for deck of card.
For deck of, yeah, that's what we have covered in the beginning of session, right? You still had doubt? Like, you understood that method or not?
That matter I understood, but in the lecture, ma'am answered these questions. That method I understand by that.
Okay, you want to understand the MEMS method, right?
Not clear.
This method.
Yes.
Okay. The ace of spade is in any one of the piles. Okay. Then the ace of spade and heart, different piles, then all four to the different ones.
First, E1 is understood, but E2, E3, E4. Not understood.
The defining of event or the computation thing?
Probability of E1 is I understood, but E2 or E2, E3, E4 not understood properly.
E2 is 39 by 51. Less than 13 by 4. Let's just okay. See, the event even is that
Is ASO spreads in any of the files.
in any of the file, and E2 was that
ASO spreads and hearts are different files.
are in different, right? Okay, then
E3 ASO spreads heart and diamond are different files.
spade, heart, and diamond. Okay, and all fours in different, right?
Yes.
Different. Okay, so see, we have in total 4 piles, right? Each pile
Yes.
has some 13 cards.
Yes.
So all my 52 cards are distributed in all of these, right? So ace of spade will definitely be in any one of it.
Yes.
Yes, because it could be one of these 13 or these 13 or these 13 or these 13. I have no other option of cards, right? All my cards are distributed already. So probability of even is 1. It's a
1.
certain event, right?
Yes.
Second one is okay, any one of these piles, right? Like of all these, let's suppose these pile, even has already occurred.
Yes.
To find E2. So suppose E1 is occurring here in this pile, right? So this pile has ace of spade, right? And 12 other cards.
Other cards here.
It could be any card, right? So if you see that now we are left with remaining 39 cards in total.
51 card, 39 cards.
39 total. Okay, and this should not contain ace of spade. It can contain any other card. Any of the other cards, right? It should not contain any ace of spade. That's my only condition. It should contain ace of heart.
Okay. That's why 51.
Yeah, ace of heart. Right? And similarly, moving forward, you can find it for all.
Okay, sir. Got it.
Okay. Anyone? Anything else?
Sir, I have a doubt. It's not really any question. It's a basic question. Like when the condition probability I'm defining, so it must also satisfy the 3 axioms of probability, right, sir? Because it's a probability.
Yeah, it will also satisfy.
So, sir, like, can you just show, like, because I was having difficulty in the mutually exclusive that.
The mutually exclusive property.
So another one, like the first one, that probability of A given B should be between 0 and 1.
Yeah.
So it means that probability of A intersection B by probability of B is less than 1.
Yeah.
So this means that this is occurring because A intersection B is a subset of B, like that. Is my logic correct?
Yeah, you can say that. Mm-hmm.
Okay, so like, can we say in general terms, like if A, E and F are there, say 2 events, and if it is a subset of 1 event, then can I say that probability of E given B is less than equals to probability of F given B, something like that?
This is my, you are saying there are 2 events, E and F, right?
Any A and B, yeah, E and F.
Disjoint or any?
One is a subset of another.
One is a subset of another. So that's just
like I'm generalizing that first.
Okay, so this is an event A, event B. So A is a subset of B.
Yes.
The
Now
probability
I'm
of
taking,
A will definitely be less than or equal to probability of B.
This we know from the previous probability law.
Okay.
Then if I take condition upon some other event, say C, given some
events.
C has occurred.
Okay, this side is C, let's say.
Yes.
Okay, this is C. Okay.
Then still the inequality holds. Or
yeah, still it holds, right? A
because,
is a subset of B. And still it is less than B.
Okay, so then the first theorem is valid, that it is less than equals to 1, since A union A intersection B is also a subset of B.
Yeah.
Okay. Yeah. Then the second one is that the sample space, if I take probability of say S given B, where S is the whole sample space, then it is S intersection B is itself B. So then probability of B by probability of B is equal to 1. Like, right, sir?
Okay, but if you have moved to conditional, your sample space has become B again.
No, I am proving the second probability, the second axiom of probability, that probability of the whole sample space is equals to 1.
Yeah, what's your whole sample space when you move to the conditional? Here it is C only, right? This remaining area is not my sample space anymore.
No, sir, I'm not talking about this example. This is the example that I was taking for another, like I was proving that if one is a subset of another, then it will be less than equals to the other.
No,
now
okay,
I'm taking just normal. Just
take this example. These are the two events, okay?
Yeah.
Now I am given that event B has occurred.
Yes.
So this is my new sample space now. I am not linked with the old sample space. This S is not meaningful to me now. Only matter of interest is this B now, because it has occurred. So my new sample space is this B only, not the complete S.
Okay.
Sample space is B now, if it is given that B has occurred. That's why if we have to find A, we do A intersection B, right? Because this is the area inside my sample space.
Yes, sir, that I have understood. I am talking about the axioms of probability, the second axiom, that probability of the whole sample space is equals to 1.
Yeah, and your sample space is B only.
And that's why it is coming equals to 1 in conditional probability also.
B given
that's what
B.
I'm saying. Yeah.
It would be B given B,
Yeah, yes, sir. The sir, mutually exclusive part I was not able to get. Like the probability of say A union B given C is equals to the sum of probability of A given C plus probability of B given C, if A and B are both mutually exclusive events.
Mutually exclusive. Okay, that would also hold. Okay, let's see. Okay, this is my event A. Right? This is my event B, and this is my event C. Okay.
Yes.
Let's see. Now it is given that B has occurred.
Yes.
So A union B, or A union C will be given B. Will be this green region plus
yes,
this green region. So what is this green region? This is A given B. A intersection B. Right? No, this is A given B. Probability of happening of A given B has occurred is this my green region, right?
Yes, sir. Okay. And that is the probability of B given C. Okay. Okay. Okay.
So that's it. Your sample space has just changed from S to B.
It becomes easy when you're applying the Venn diagrams, but like when I was doing in mathematical, it was a bit of calculations is there.
Yeah, don't like Venn diagrams solves a lot of problem in probability. It's very helpful too.
Yeah. Thank you, sir.
Okay, anyone, anything else? Anything from week 7, 6, anything?
Sir, activity question 8.2, question number 2.
8.2 question number 2. There are n balls not drawn. Okay, 7 are red. If 2 balls are chosen randomly, both are red is 3/4. Okay. Yeah, just for a conditional probability. Okay. Wait, there is, let's say, some bag, right? You have 7 red balls, and in total you have n balls, right? And you have chosen 2 balls randomly. You are given that probability both red is something 3/4. You have to find n, right? This is the question statement. It's
Yes.
elaborated, but okay. So see, 2 balls. So let's define 2 events, right? Probability that well, I think we can do it more simpler way. Okay, yeah. See, when will I get both the red balls? Like it's just like choosing from these 7, right? 7C2. And in general, my total possibilities are NC2 because in total I have n balls.
Yes.
It's given to me as 3/4. You can solve it, right? So I mean, you can solve it. This quadratic equation. 1n will be, I think, some negative or maybe.
It's 7 into 8. That is n equals to 8.
N equals 8, is it? And into n minus 1, 7. Yeah, n equals 7.
N equals to 8. 3 into 6. That is come 2. 7 into 2 divided equals to divided by 1/4. So 7 into 8.
N
That
equals
means 8. Yes, that is common. N is equals to 8.
Thank you, sir.
You can also define events and do it. That first ball is red, then second ball is red, right?
Yes.
So you have to find E1 intersection E2.
Yes.
Which is same as like first ball is red into second ball is red given first is red. Okay. So first being red is just 7/n.
7 out of n.
One ball has already been drawn. I'm
Yes.
left with n minus 1 and one red is drawn. You will get the same equation.
Yes. So we have to solve it like a quadratic.
Yeah.
Okay.
You can do it either way, defining events or going like that. It's up to you. It's not necessary you have to use conditional every time.
Okay.
Okay. Anyone? Anything else? Week 7 related assignment, was it clear? Were you able to solve all the questions?
Sir, can you go in the assignment GA4?
GA4.
Because we have plenty of time, so we are able to do GA, but this type of questions, it's difficult to solve in the exam.
Which type of question?
Few difficult questions are there. Na?
Sorry, sir. It's GA7, question number 4.
Okay, GA7. Okay. Question number 4. Okay. I think our values are different. Can you tell me your values? Go for that.
There are a total of 150 students who are part of badminton
150
table,
students, right?
and of which 60% of students play table tennis.
Okay.
And 30% play tennis. 60% play badminton.
Okay.
It is also noted that all the students who play tennis also play table tennis, but not badminton. Now, student is selected at random. What is the probability that he see is the part of the table tennis team only.
Okay, so what do you understand by this statement? That all the students who play tennis also play table tennis, but not badminton. Okay, if we try to draw it in some sense, okay, let's say this is my table tennis area. This is my badminton area, right? In total, I have 150 students. All the students who play tennis also play table tennis, right? So tennis area should be inside my table tennis area, right?
Yes, sir.
But they don't play badminton, so it should not go to the region of B. So it should lie only in the TT region. My tennis, right?
Yes, sir.
So this thing implies that T is a subset of table tennis. It's just English translation of statements to events. That's what you have to identify always. So drawing Venn diagram also solves it a bit. All those who play tennis should lie in the TT region, but not in the badminton region. Okay. Now see, in total I have 150 students, right? 30% play tennis. 30% of 150 is nothing but 45 students, right? So 45 students are in this region. Okay. 60% play badminton. 60% means 90 students. So 90 students play badminton. And table tennis also play 90. So if you notice that this TT region, use some different color, this TT region excluding the tennis one, right? This region will be nothing but 90 minus 45, right? It means this blue region is 45. And you see that this blue region and this complete B region, it is coming out to be 135 and 45 students are here. So total I am getting is 180, but my total should be 150. If you know that 30 students are counted twice, who are these 30 students? These 30 students are this intersection region being counted twice. We counted them in TT, we counted them in badminton as well. I have to subtract 30 more. So only 15 students play only table tennis. Okay, which would be something this region only. Right, so now probability will be just 15 out of the total 150, which is 0.1. So drawing Venn diagram will definitely solve these problems a bit easily.
Okay, sir, I got it. I made some mistake. Okay, sir, got it. Thank you.
Okay.
Question number 2, sir.
Question number 2 of same.
Graded 7.
Sir, question number 3.
Yes,
Oh.
graded.
This one, right?
Yes, my sir. Okay, in my question there are given is 4 options.
Okay, 4 options. Okay.
Yes, so that could be 4C. One option is correct.
Yeah, A is one of the answer. If only one option is correct, then it's A only. If 2 options are correct, it could be anything. A comma
Yes.
B.
In the
A
question
comma.
say A is correct.
Yeah,
so,
A is one of the answer.
So answer in the answer given is 8. So A is correct means 4C1. I have 4 options.
No. If only one option is correct, right?
Yes.
Then it only possibility is A, because A is already correct. It is given to you. If 2 options are correct, then it could be A and some other of these B, C, D, right? It could be 3, choose one, any one of these 3. So you will have 3 ways. If 3 options are correct, then A will definitely be here. You will have to just fill 2 more spaces of these 3. So that 3C 2 ways, right? Again 3. If 4 options are correct, then all 4 will be here.
Okay, I cannot understood question properly.
Okay, it is.
So why should we use 3p2?
3p2 because if you write a comma b or b comma a, it's same, right? Then permutation we use when order matters, but here order doesn't.
So please explain ninth question also.
Ninth question.
Sorry,
This
could
one.
you also explain 8 before that?
Yeah, 8,
Because
9,
it's the
10.
same question, yeah.
Okay, Pramod goes to shop. Okay. I think, can you tell me your numbers? It's different for everyone. Just anyone. Like how many pants, shirt, t-shirts are there?
9,
Sir,
5,
mine
14.
are 8, 7, 10.
Just tell me in this order: pant, shirt, and t-shirt, right? These are the things.
9,
9,
5,
5,
14.
14. Okay. And the question 8 is you have to find all of different, right?
Yes, sir.
So in total, I am choosing only 3. So total are 15, 14, 19, 28. So out of 28, I am choosing 3 objects in total. That's my total, right? Moving
Sir,
on to yeah.
sorry, sir. Order was shirt, pant, and t-shirt.
Shirt, pant, and t-shirt, right?
Yes, sir.
Okay. So now all different means I should get one from it, and one from it, right? My 3 objects will be selected. So of this 9, I can choose anyone. Of these 5, I can choose anyone. And of those 14, I can choose anyone. So that would be our answer, right? Is this clear?
Yes, sir.
Okay. And question 9 was?
It should not contain pant.
Okay, no pant. Okay. You see, so again, total ways of selecting are 28 C3, right? I can select any 3 of these 28. Now my favorable is there should be no pant. So I am only left with these 9 and 14, these 23 options only. So I have to choose only 3 of these remaining 23. So that's probability of getting no pant, right? In my favorable outcome, there is no pant. In total, I can have any, right?
Okay.
Sir, can you explain question number 3?
Sir, just
One by
one
one.
minute. Here we are saying no pants, so that means from 28 we removed 5 pants.
Yeah, I can choose only from these, right? 9 and 14. I cannot go into the pant. Cannot choose
And
pant.
how would we do then question 10?
Question 10 is
That at least one is a shirt.
at least one shirt, right?
Yes.
You can find 1 minus probability no shirt.
Yes.
At least one shirt means either should have 1 shirt, 2 shirt, or 3 shirt. So
yes.
If I subtract that, I have 0 shirt, I will cover all these cases, right?
Yes.
So again, no shirt is, I can choose any of these 19, right? I can choose 5 pants and 14 t-shirts are my option to choose from only.
Sir, if question was at least 2 shirts.
At least 2 shirts. Okay,
Yes,
so
sir.
here you will have to make the cases. One case is I select 2 shirts or 3 shirts. These are the only possibility, right? For the 2
Yes,
shirt,
sir.
it would be I choose 9. From this 9 shirt, I choose 2. And from the remaining 19, I choose only 1. Total is 28 C3 again. And for 3 shirt, it would be I choose all the 3 from those 9 and adding them, either 2 shirt or 3 shirt, right? So adding. You'll get it, right?
Okay.
this question you can also do it like that, like one shirt first, doing that case, right?
Yes. Yeah.
And then going for 2 shirt, and then going for 3 shirt. So you will get the same answer by computing like this or this.
Yes. So can we go for question number 3?
Question number 3. What is it? Okay. Probability that at least 2 of his predictions are correct. Here we have Titan, products, and fossil. Titan, products, and fossil, right? At least 2 should be correct, right? So at least 2 means either these 2 are correct, this is wrong. These 2 are correct, this is wrong. And this is wrong, these 2 are correct, right? And the fourth possibility is all 3 are correct. We just have to find the probability for all the 4 cases and add up, right? And all of these are independent because these are different brands, different going up and down stocks, right? So these are the 4 cases. Mostly students miss this case. Most of the cases. Yeah. If all 3 are correct, you are still satisfying the at least 2 condition.
After doing the addition rules, so इसको add करेंगे sir ना?
Yeah, either this will happen or this will add them all. Right.
So if it is intersection, what do you do? Subtract.
Intersection, like how is intersection subtraction linked?
Like, I mean, see here we are taking all the 4 shirts, any of those 4 cases. So probability we are adding. Let's say it should be for sure 2 of these cases. In that case, we take the intersection and what do we do?
Yeah, if these all 4 are disjoint, right?
Yes.
If they are not disjoint, we subtract the common part, adding the individuals, and then we subtract the common part.
Okay.
Yeah. Anyone, anything else?
So 11 question number 11.
Okay. 8th question we just discussed, right?
7, sir.
7, that's also same. We have after 26 black, you have to choose 5 and
No, sir. 11.
Okay, 11. Okay.
Yes, sir. 11.
Okay.
23 by 20.
12th question you were able to do?
Yeah.
Yes, sir.
Okay, that's great. Okay. 1, 2, 3. Okay. So if you notice that I have to fill these 3 spots, right? P, Q, and C, and I'm doing with replacement. So any of the 3 number can come here, any of the 3 can come here, any of the 3 can come here, right? So in total, I have 27 ways to get the value of P, Q, and C, right? These are my total. Now I have to find the favorable. For favorable, I have to choose those value of P, Q, and C such that it's B square, Q square minus 4PC, right? Q square minus 4 times PC should be less than 0, right? Were you able to understand question till this point?
Yes.
Yes.
Okay. Let me just reverse the condition. I can do it 1 minus all those cases where Q square minus 4PC is greater than or equal to 0. Right? We can do it, right?
Yes.
Okay. So let's try to find the value. Right. Okay. So one possibility is my PC, the product, this PC. It could be 1, right? When will it be 1? When my both P and C are 1, right? And what all values Q can take such that Q square minus 4PC is greater than equal to 0, right? These cases I have to count basically. So if my P and C are 1 each, right? If my Q takes the value 1, so it would be 1 minus 4. So it will go less than 0. It won't satisfy my condition, right? So it is not possible over here. If I take Q as 2, then 2 squared is 4 minus 4. So 2 can be one of the value, right? And similarly, if I take Q as 3, then also 9 times minus 4, it's still greater than 0, right? So these are the only two values Q can take when both P and C are 1, right? So I have two cases for this. Next is PC can take value 2. Yeah. Any doubt till now?
No.
Okay. So PC can take value 2 if either my P is 2, C is 1, or the reverse. Okay, so if P into C is 2, then 4 times PC becomes 8, right? So my Q square should be greater than equal to 8, right? It is only possible when Q is 3.
Yes.
So one case is that my P is 1, P is 2, C is 1, and Q is 3. And the other case is P is 1, C is 2, and Q is 3. So in total, I have 4 ways when this condition is satisfied out of total 27. So 1 minus 4 by 27. If you want to calculate this case, you can count, it will be 23 cases in total, like that.
Got it, sir. Thank you.
Question number 12.
Question number 12. Okay. If A and B are mutually exclusive and disjoint event, so see, this is my Venn diagram. I'm just drawing it a bit like that. My two events A and B are disjoint, right? So if you notice that, what is my B complement? B complement is all the region except this B, right? So you see that A is a subset of B complement. So probability of A is less than equal to, right?
Hi sir, if both of these are supposed to be mutually exclusive disjoint events, why will not the probability of A not equal to probability of B?
Why would it be the same? It's not necessary that both should be equal to 0.5, right? Could be that A is 0.3 and B is
0.7, yeah.
Not necessarily always equal.
Okay,
that's
but
why, yeah.
This is not the case with dice and stuff, right? I mean, in a dice, you know that for any number to fall, it is just 1 by 6, the probability.
If it is a fair die.
Yeah,
not
if
always.
it is, yeah.
Okay, that's why this word always is also mentioned here. Which of the following is always true? Okay.
So can we use formula for this to solve?
Formula you can do, it's given in the solution PDF as well, but it would be a bit tricky. Personally, even I do all the questions by Venn diagram. I don't go into that formula things.
Thank you.
Sir, activity 8.33, question 3.
Yeah, I too had the same doubt.
8.3, question number 3, right?
Yes.
Did that box with 5. Okay. 5. In total, you have 12 marbles, right?
Yes. 19 and 12. Yes.
5 red, 5 blue, 3 red, 4 yellow. 5 blue,
3 red.
4 yellow, right?
4
and you have
yellow.
to find the probability that pulling out a blue
One
marble
is
followed by
blue
yellow.
marble given by, followed by.
So first you should draw yellow, and then you should draw blue followed by yellow, right?
Okay.
So this is your only one favorable outcome, right? Your total outcome is you can draw any of the 12 in the first row, and you are also putting
Sir,
it
it
back.
should be probability of yellow given blue.
Yellow given, yeah, you can do
Followed
it
by
like yellow given. Okay, if you want to do like that, you can do it like that as well. Okay, so that way is just you made the event. E1 is that first one is yellow. E2 is second one is I think blue. You can also do it like that. It's not so. In general, you have to find E1 intersection E2.
Yeah, I did this method, but still didn't get the answer.
E1 into E2 given E1, right? So E1 is first is yellow. So 4 by 12, right? And after drawing, you are putting it back. So again, you have 12 possibilities. And it should be blue. So 5. So 20 over 1 for 4. So cut it would be nothing but 5 over 36. Right?
Sir, I wanted to ask, in a deck of cards, the ace is not part of a face card, is it?
Yeah, it is not a part of face card.
So like in activity 8.2, I think
Only
question
Queen and
number 3, they're asking what is the probability that when if you draw one card at random.
Which question?
8.2.
8.2, okay.
Question 3.
Face cards never contain ace, so that is 0.
This is 0, right?
Yeah, it is 0.
Okay, thank you.
Yeah, it is 0. Okay, anything else? Anyone? Yeah, the way we are doing with Venn diagram, you can also do all the question by contingency tables as well. Yeah, so do give it a try as well. And there is one more method, which is a tree method. Ma'am will cover it in the revision session for week 7. So doing one question, you have kind of now 4 ways to do, right? One Venn diagram we are doing today. Theoretical method you did in the lectures. And tree method ma'am will teach in our revision session. Okay.
When will that be, sir?
We are planning to put it a week before, like between 6 to 12 March in between.
Sir, when will the course content for 9-week to 12-week release?
Week 9 is already released. Week 10 will also release next Friday.
Okay. Said I didn't.
Week 9 is not. Okay, today's Friday, right? It will release today.
Yeah. Okay. Said.
Every Friday it release. It keeps getting released.
Okay.
Okay. And yeah, we have also put the first week 5-6 math revision session slides along with solution here, so you can go through that. And these are the only, I think, questions in permutation combination you can ever face. It covers all the 20 questions, and it contains question from previous quiz paper as well.
What will be the syllabus for the quiz that is coming, sir?
Week 1 to 8, with main focus on week 5 to 8.
5 to 8, okay.
Yeah, but week 1 to 4 questions will also be there. You can expect.
Mixed, I believe.
Antum will also be most likely equally distributed, more or less. But yeah, obviously main weightage goes to 9 to 12. Okay, and in quiz 2 you are having EMQ, right? You are aware of it.
But EMQ is optional, right?
Yeah, optional question. Yeah, you can just get some bonus marks. So out of 50, you can attempt 54 marks paper, something like that. That NAT question, if you did it wrong, there will be EMQ asking step questions. So if this is wrong, you can still gain some marks by answering steps right. You will see such question in mock as well.
So will there be any negative marking?
See, EMQ will be an MSQ type. Okay, suppose there are 6 options. A, B, C. So let's say 2 are correct, A and D are correct, right? And if you answer only A, you will get 1/2. If you answer both A and D, you will get 1 for sure. But if you answer any one wrong option, you will get 0. So that's the condition. So it would be MSQ type marking like we have.
Okay, sir.
And this question will only be evaluated if you answer the above NAT question wrong. Otherwise, it won't be checked. So maximum marks is still 50 only.
If wrong, NAT.
Yeah, suppose answer to NAT is 20, but you have did some calculation mistake, you have written 21. So in general, you loses all the 3 or 4 marks, right? But now you will have this MSQ question, this EMQ pattern type. If you answer it correct, you can still gain 1 or 2 marks. Oh, and you won't lose all the 3 or 4 marks straightforward. You can still gain 1 or 2 marks, right?
Okay, good. Thank you.
Yeah. Anyone, anything else?
So, sir, in EMQ, we write the answers in the notepad and then we submit
No,
it. So
in the
exam.
quiz, it will be MSQ type. You just have to
Okay.
tick, yeah, and just move forward. You won't be that complicated. Because in quiz, there will be only steps asking, not the numeric values.
Okay, sir.
Okay, anyone, anything else?
I have questions, sir.
Yeah.
8.14. Why my answer come wrong?
Which one? 8.1.
4.
Okay. Defaulted
Answer
in
is
lower.
given 0.2, but my answer come is, let's check, 0.4, question number 4.
Given
My
that
answer comes
is
0.1, but answer given 0.2.
0.2, yeah, it is 0.2. See, what is given to you? You have to find that the person has defaulted the loan, given that the person is a chef, right?
Yes.
So given that he's a chef means your sample space is now this third column only. This 250
Yes.
peoples. Out of those, 50 has defaulted the loan. So 50 over 250 is 0.2.
Okay, I am choosing only 50.
No. You see, that's how you can also use contingency table to solve conditional probability question. It is given to you that the person is a chef, right? So it is given to you
Yes.
that we are talking about only these 250 people, nothing else.
Okay,
Out of
sir,
those 250, 50 defaulted.
Okay, that's why I come. Okay, sir.
Yeah.
Thanks, sir.
So if some word problem is given to you and you can draw this contingency table, like you draw Venn diagram, you have one option. You can also draw this table and then solve the question as well. It also makes the
Okay.
problem a lot easy. Like here the questions, I think it was pretty easy to solve
Yes.
using this table. So if you can draw this table from word problem, you can still do the questions.
Okay, sir.
Okay. Anyone, anything else? And is 8 to 10 timing good for solve with us? For everyone?
Yes.
Yes, sir.
Yes, fine, actually.
Sir, could you also look at activity question 8.2, question number 4?
8.2, question number 4. Yes.
What does
test
it mean, land on 5?
Means it is when you roll a die, you got the number 5. That's what it
Only the cases where the first die is 5.
Yeah. At least one of the die lands on 5, given that their sum is 11. So if you try to solve it, it would be something like sum is 11 given to you, right?
Yes.
So your new sample space will be
5.
whenever sum is 11. Yeah, 5, 6, 6, 5, nothing else, right? Yeah. And you have to find the probability that first die is 5.
At least one is 5.
At least one is 5. Okay. At least one is 5 given sum is 11, right?
Yes.
So that's both, right? 1.
Oh, okay. Sir, actually the language was a bit confusing. It's saying lands on 5. So I thought maybe 5 would be face down on the floor.
Then also it's the same thing, right? Any number can be face down. It means you are noticing the number which is face down only.
No. What I understood was landing on 5 would mean 5 is hidden from you.
Okay,
And some other number would be shown on top.
No, it's not like that. Lands on 5 means the top number is 5. It should be.
Okay.
Hello.
Yeah.
Sir, I have a problem in week 7.
Week 7.
Tutorial 7 actually.
Tutorial 7. Okay, was it? Yes. Oops. And the portal is down, I think. Okay, let's just switch. Is it for everyone or is it only for me?
No, sir, it is for everyone. I am also
Yes, sir,
facing
it's
this
for
problem right
everyone.
now.
Okay, so I think the portal is under some maintenance because diploma level guys have some exam tomorrow.
Okay.
And also week 9 is released. So maybe
when it will be corrected?
In 10 to 15 minutes it will be.
Okay,
maximum.
okay.
Can you tell me the problem so we can do if you remember it?
So I just mentioned the number. I don't know the problem right now.
Okay. Anyone else? No. Do we have PDF for that? I think so. Have it, right? Okay, I can fetch it. Or just give me a minute. Okay, so it's 7. Yeah, so we can do it now. Okay. Question number 7, this one, right?
Tutorial 7. Yes, sir. Yes, sir. This.
Engineering college. Okay. So where did you face a problem? That 20C temple?
Sir, I am not able to how to initiate this problem.
How to initiate this problem? Okay. Okay. So if you notice, there are in total 20 rooms, right?
Yes.
And you have 2 types: civil engineers and computer engineer, I think, right?
Yes, sir.
Okay. So you have 20 each. So, and you want that all civil engineers be in the same room and all computer be in the same, like
No.
that civil and
No.
computer should not be a partner in a room, right? Something like that.
Yes. Yes, sir.
Okay. So it means that 10 rooms should belong to the civil ones, and similarly 10 rooms should belong to the computer engineer, right?
Yes.
Okay. So out of those 20, any 10 can belong to the civil engineers.
Yes.
So I can choose any 10 rooms out of the 20 for civil engineer. After choosing for civil engineer, I'm left with only 10 rooms now. And I have to choose 10 for computer engineers, right? Okay. Once the rooms are chosen, now I have to fill the rooms. Suppose these 10 are for the civil engineers, these 10 are for computer engineer, right? Of all the 20, any two can come to the room 1. With 18, any two can come to the second room. Any two. Similarly, for computer, you have 20, any two can come to the first room, remaining 18, any two second.
Yes, sir.
Multiply them all, you will get the answer.
Okay.
You won't be given such tedious calculations, but yeah, that's the approach.
Okay, okay. So activity 7.1, question number 5.
1 minute. Activity 7.1, right?
Yes, sir.
Question number 5. Choose the incorrect statement among the following. This one.
1 second. Yes, sir.
Well, choose the incorrect statement among the following. An outcome is a result of an experiment. Yes, it is. A set of all possible. Yes. Yes, I think none of the above.
An event is a subset of sample space.
Yeah. Any event is subset of sample space. Okay. Suppose you are throwing a die. Okay. Your possible outcomes are. Now define any event. Even number.
Yes, yes.
Odd number.
It will be the subset of sample space.
Prime number. Anything you can write, right? Everything is a subset. As many you can define.
Okay.
Okay. Yeah.
Okay.
Anyone? Anything else?
I have a confusion in the lecture 8.3.
Lecture I can't open over here.
The deck of chord problem.
Yeah, we have discussed it.
Okay.
Yeah, we have discussed it in 2 ways. Yeah. One the MEMS way and the other way. Okay. Anyone else? Any other?
No, sir.
And yeah, VCAD also has the EMQ as practice assignment. You can do that. And I think week 8 is the last EMQ, maybe, or week 9 maximum it can go. Okay. Okay, anyone, anything else? Shall we close?
So week 8, this is only a practice assignment, right? EMQ.
Yeah, everywhere it is practice assignment except the week 5.
Yeah, that I don't know. I tried running it for like 5-6 times and I was fed up. I just gave whatever it was. It only recorded 11 out of 11, only 7 answers were recorded.
Okay, I think you should have checked the format over here.
I did.
It should be like that. You may be giving some spaces over there.
Might be. Sir, in the exam, we will be having notepad and we can write the numbers over there.
Can you repeat?
The real-time quiz. We will be having.
There you will have just MSQ. Suppose these 6 are the options. It will be given you as 6 options. You have to just take
okay, like 1, 2, 3, 4. Yeah. Okay, I got
Sir.
it.
Yeah.
Sir, in 7.1, question number 5.
Yeah.
The option 2, I think it is correct. The set of all possible outcomes.
Yeah, it is correct. You have to choose the incorrect statement.
Okay.
So all 3 are correct, A, B, and C.
So, sir, we will not have any EMQs in the end term or the graded assignments for coming weeks, right?
For graded assignment you want, but end term you may have.
Okay.
Yeah, that's
End
why we are
term is
giving you
divided
practice.
into 2 parts. Then in that case,
No. It will be only optional type question like we are embedding in quiz 2. Just like you will see in the mock.
okay, but I mean, you just have to pick up those choices instead of writing that in a test file, right?
Yeah, you just have to take like MSQ, like in MSQ question we take, right?
Yeah, that is fine, but this EMQ was bit of tardy.
Yeah, it's just an experiment. So setting up a whole portal according to that takes some time.
Yeah, true.
Okay, anyone, anything else? Not still lacking. Right, still. Okay, anything else or shall we close?
Sir, if in any question it is said that you need to select even numbers, should we count it 0 in it?
No.
Yeah, 0 is.
Because in this question, one question has counted 0 in this.
Yeah, 0 is a even number.
In statistics.
In math, it isn't. Math also
In
considers 0
CT,
as natural.
yes. No. 0 is not a even number nor.
Yeah,
Yes,
exactly.
it
0
is a
is
natural
considered to
number.
be a non-even natural number, no?
Your maths consider 0 as natural number.
Yes, sir.
Yeah, rest other courses take natural number from 1 to something.
Okay, means if in question it takes 0, then we need to count it as even number.
Yeah, in stat it's
Okay.
an even number.
Okay.
Okay, anyone, anything else?
When it comes to dice question, actually,
Yeah.
I did mistake. In dice, I took 0. When I saw even, I took 0, like that. So be alert
But
in that.
0 is not a possibility. It's not in sample
Yes.
space. Yeah.
Exactly.
Hello.
Yeah.
Sir, in lecture 7.2, I was one problem.
I can't open lectures.
7.2, 23 minutes.
No, I don't think I can open lectures from here. The 1 minute I have to fetch it. 1 minute. 7.2, right?
Yes, sir.
So now I can't fetch lectures from here. You remember the question? Something.
Sir, 1 second.
Yeah, till then someone's asking something, right?
Sir, instead you can probably try directly opening it from YouTube, apart from the portal.
Yeah, I have to look for it. I think.
Nice song.
Shoot. This one, right?
Yeah.
Okay, which time frame?
23 it seems.
23, it's ending already. This one. It's ending the lecture here, 23rd minute. It would be some other, I think.
Is he there or not? I don't know. He's not responding.
Is my voice audible?
Yeah, sir.
Okay.
Sir, there is one question, I think, in which event should be, I think, 5 factorial plus 5 factorial minus 1.
In this lecture?
So,
this one, right? 5 factorial, 5 factorial.
yes, sir.
This one, right?
Yes, sir. Yes, sir.
Okay, so
why will it be -1?
Why did you -1? Because if you see the case, this A comes first and B comes second.
Yes, sir.
It won't be -1. It would be minus something 4 factorial. It would be -4 factorial, right? Because 4 factorial cases will have both intersection thing.
No, ma'am has given that 5 factorial plus 5 factorial will be the events.
Will be the events. For even it will be 5 factorial possibilities. Okay? Because A should finish first, rest all 5 you can arrange in 5 factorial
Yes,
ways.
sir. Yes, sir.
In second also B comes second, remaining 5 places you can arrange in 5 factorial ways.
But sir, one case will be common in both E1 and E2.
Not one case, 4 factorial case will be common. When both A and B occupies the first 2 position.
Yes, sir.
And remaining 4 you can arrange in 4 factorial ways. So that would be 5 factorial plus 5 factorial minus 4 factorial cases for E1 union E2.
Okay. Means total events will be 5 factorial plus 5 factorial minus 4 factorial.
Yeah.
Okay.
Okay, yeah. Anyone, anything else?
Sir, why is it -4 factorial?
Okay. If you see that E1 is that A comes first, right?
Yes.
And E2 is B comes second.
Yes.
So if you make cases like A should occupy this place, remaining 5% in remaining 5 places you can arrange in 5
5
factorial.
factorial is, yes.
Similarly here, B occupies this place.
Yes.
Remaining 5 you can.
Yes.
5 factorial ways. Now E1 intersection E2.
Yes.
It means that first 2 positions are occupied by A
By
and B.
A and B, yes.
Remaining 4 you can arrange in. So E1 union E2 will have E1 plus E2 minus intersection cases.
Okay. So it was either A comes in first place or B comes in second place.
Yeah. So here we are counting these factorial cases twice.
Okay. Okay. Thank you.
You can also take 4 factorial common and then go by like this. You can solve it like that also.
Okay.
Sir, tutorial 4 of week 7.
Tutorial 4 of week 7. Okay.
Actually, I am not able to see the question right now. The portal is not working.
Yeah, you can see it here. Question 4, this one, right?
Yes, sir. Tutorial 4.
Mary got the feedback and Asid did. Okay.
Yes, sir.
1000 randomly selected students. Okay. Okay. So out of these, see, there are 30,000 students, right?
Yes, sir.
And I'm giving my
1000
feedback
selected.
for 2000 only.
Mhm.
So what is the probability that anyone will get the feedback form is 1000 by 30,000, right? And probability that one didn't get it it would be just
1 minus
29 by 30, right?
yes.
So two students are independent, right? That Mary and that's a Masif, right? Is it something like that? Mary and Asad, right? Mary got the feedback form and Asad didn't. You have to find probability Mary intersection Asad didn't, right?
Yes.
Then these two events are independent, it won't be. How do I know it is independent? Because we are randomly distributing among 1,000 students, right? So whenever the word random comes in, it means independent. So M getting is 1,000 by 30,000, and it is 29. We'll solve it.
Okay. Thank you.
Okay. Anyone, anything else? Or shall we close for today?
So how we took A complement value as 29,000 by 30,000?
Because probability of anyone getting is, we are distributing only to 1,000 students, right? So one getting the form is 1,000 but 30,000 probability, right? Like it's just like you are given 100 numbers, selecting anyone, it's 1 by 100, right? Selecting the number 5 of first 100 numbers. So it's just like of those 30,000 students, selecting anyone is 1,000 by 30,000 because 1,000 persons are getting it, right? My favorable outcomes are 1,000 and total are this. So probability that one gets the feedback form is favorable upon total, which is 1,000 by 30,000, right?
So A complement means no one will get the form feedback.
That 1%, anyone, any single person didn't get it. See, of those 30,000 students, you pick one student randomly. Of him, getting the feedback form is 1,000 by 30. 1,000 by 30,000. And of him not getting the feedback form is 29,000 by 30,000, right?
Okay, sir.
Okay. Anything else? Anyone?
Sir, 8.3 question 4.
8.3 question 4. Okay. This one, right? What is the probability that all three are girls?
I'm getting confused in these kind of questions. I don't know why.
Okay, see, in total you have 14 students, right?
Yes.
6 girls and 8 boys. So total ways to choose 3 students is 14C3,
14C3,
right?
yes.
Your favorable is all 3 should be girls.
Yes.
So favorable upon total is your probability, right?
Okay. Okay, it's very easy. I don't know why I get confused. Okay.
That's why permutation combination is taught before these. This concept will be used in this week 7, 8 everywhere.
Okay.
Anything else? Or shall we close?
No, sir. Thank you.
Okay. Thank you, everyone.
Thank you, sir.